case you haven't noticed, this is the all-female review of the nutrient loss reduction strategy. How many of you guys ever thought you'd see that happen? An ag meeting and all the presenters are women. But we saved the best for last. We're going to bring a couple guys up here toward the end. All right. So I get the pleasure today of talking about fertilizer, which is, of course, a nutrient. Oh, thank you, Jennifer, for queuing up. We've only done 10 meetings. I can't believe we forgot to do this part. Jennifer and Lauren and Laura Gentry and I could give each other's presentations by now, but nobody wants to do Lauren's portion of the program. So I'm going to talk to you guys about the 4 R's, and this has been a collaborative effort that actually the Fertilizer Institute started 4 or 5 years ago. And I want to start this conversation by telling you that the reason we're here today is because Illinois agriculture has been extremely proactive, you guys. We saw these issues coming probably 5 or 6 years ago, knew that the US EPA was going to be requiring all these nutrient loss reduction strategies. The issue that we had in Illinois is, as you see this coming down the pike, at the very same time our state government was truly struggling with our budget issues. You guys know what's happened to the Extension Service. You know what's happened to funding to higher education and research. So at a time where we see this biggest issue that impacts you on your farm, we really have no structural emphasis to how we are going to support these efforts, which is why today we have the Nutrient Research and Education Council, because your ag groups thought ahead and went to our General Assembly with a proactive idea. We didn't wait to react to this. Could you imagine if this document came out and we have all these challenges on nitrogen and phosphorus and we had nothing but, will someone please help us? Now we have ownership of this issue, and it's so important, and I think it's the main reason that when you see what's going on in Ohio, if you guys farmed in Ohio today, you would have to get certified to buy fertilizer to apply it on your own farm. All the fertilizer retailers in Ohio have to be certified for our providers. Their records have to be audited. In Ohio, I'm going to read you just a portion of the legislation that passed out there after the problems with Lake Erie. In Ohio, as a farmer or a fertilizer dealer, you have to wake up in the morning and you have to turn on the local weather forecast, because if the local weather forecast calls for a greater than 50% chance of rain exceeding 1 inch in a 12-hour period, you cannot apply fertilizer. And the rest of this act, that's about 20 pages long, is all about enforcement. So that's life for the farmers in Ohio. We have the lawsuits in Iowa, we have regulations in Minnesota. This is kind of a scary time, but agriculture in Illinois, I think, can stay ahead of this. But because we farm over tile drainage in this part of the state, it is going to take more management. Now you guys drive around, the fields that look the best out there after all this rain is where we have good drainage, right? So we like our tile drainage, it's great for crop production, but it is going to require you to manage your nitrogen in a more careful and thoughtful way. You cannot just take for granted that we are moving more water off of our fields. Now the nice thing about everything that I'm going to talk about is that it's being backed up by what Lauren mentioned, the peer-reviewed published research. US EPA told the states, we want your programs to be science-based, but we'll only accept land-grant published peer-reviewed research, or research from universities that other people can look at and say, yes, this is credible. So without that backbone, we cannot change those things in that strategy document that you read. If we want to add to it, if we want to find new researchers, better ways to reduce our nutrient losses, we have to have our universities backing us up. And Dr. Hayes is going to talk about a project just a little bit north of here that's doing just that. So NREC has really reinvigorated nutrient research again in Illinois. So let's talk a little bit about nitrogen management quickly. What are we doing and how are we doing it? Can we manage our nitrogen in a systems approach? The whole goal is really to avoid those catastrophic losses of nitrogen that you can see if you put your full rate out at one time and then the weather does not cooperate. Now we had a catastrophic loss of nitrogen in the spring of 2013. The nitrogen that was left over from the crop of 2012 all got into Lake Bloomington, Lake Springfield, Lake Decatur. We had the worst water quality in central Illinois that we have had in recent history because of nitrogen losses from our tile drain fields. Now, did you see terrible, onerous headlines in the papers about that like you see in Iowa? You didn't, because we owned the issue, we worked with our water supply people, we have relationships with all of them, and we told them that we were aware of what had happened, this is why it happened, and we were going to work together to keep it from happening in the future. And that's the difference between Illinois and the lawsuits in Iowa, is that we have really claimed ownership of this issue. So the maximum return to nitrogen calculator is one of the items in your document. The government wants to have a trust that the industry and the farmer is using the right nitrogen rate. Now, right is a tough word because you can only be right if you know exactly how much it's going to rain and when. But we can use the science available to us to pick a nitrogen rate that is going to be a good guideline for you, and it's never going to be exact, but it's the most profitable range for you, and it promises that it will deliver your profits without leaving excess nitrogen that will be susceptible to loss. This is a picture of a nitrogen rate trial. The first year that NREC funded this, we had, I think, 13 nitrogen rate trials. Last year we had 37. This year we have 62, and these are all on farm. The beauty of NREC is it's pushed the research off of the basic university campus out to your farm fields. These are not difficult to do with the nitrogen rate controllers that we have in our toolbars and the mapping software that's readily available. So you can see the replicated trials. This is on a farmer's field. At the end of harvest, you take the harvest and you can determine what that optimum rate was. Now, for all the farmers who participate, we pay them $1,000 because there's some 0 and 50 control zones in there, and we lose some yield, but they're compensated for that. But we feed this information to the University of Illinois, they analyze it, and then they put it in perspective from a management tool. And so the thing about the MRTN, if you've never used it before or never looked at it, we encourage you to, because if you had used the maximum return to nitrogen calculator, the orange dot is where that rate, that recommendation would have come out. If you look at what actually occurred in the rate trials, those little yellow diamonds, that was what truly occurred on the farm, but look how it flattens out. There wasn't a lot of extra yield picked up for that extra nitrogen. So if you've never used the MRTN, I ask you to take a look at it, talk to your fertilizer dealer about it, be confident in your nitrogen rate, because I tell you what, for these 62 farmers this year that did this, we always have to also think about if the regulations come, you guys, and you've done this research on your farm, and you know what your optimum rate is, and someone comes in and tells you, no, we think it should be 185 pounds. And you say, you know what? For me, it was 200, because I've got the proof. That's a powerful thing about on-farm research, is it lets you be in control of what's going on your farm. And also, you can split your nitrogen rates. It used to be the nitrogen rate calculator threw out a rate, and then that's all you had. Here's your rate. Now, on the CBMP website, we have created these tools where you can say, I'm going to put so much on in the fall, some pre-plant, some side dress, I'm going to add in my nitrification inhibitors, I'm going to experiment around with the application costs, and it'll kick you out a nice multiple application spreadsheet for you to follow. And this is also on the iPad or the Android system, so all available on the CBMP website. Now I'm going to segue a little bit into why we in the fertilizer industry had a lot of concerns about the nutrient loss reduction strategy, because the only peer-reviewed research that was available on fall applied nitrogen came from Iowa, and it's not a very recent paper. So one study says it's better to put all your fertilizer on in the spring. Well, here in Illinois, we're doing some research because we feel that management of fall applied nitrogen is important for Illinois. Now, how many of you guys fall apply some of your ammonia? Okay, this is a big part of the state for that. If you look at our nitrogen sources in Illinois, our state has a phenomenal logistical system. This Illinois was set up to deliver 82% nitrogen to you in a very efficient way. We have 13 ammonia terminals on the pipeline, which means we don't have to rely on the railroads and we don't have to rely on the barges to always get it to us. So 60% of the nitrogen that goes out there is in the form of anhydrous ammonia. Typically, when you think about spring applied fertilizer, if you look at Ohio and Indiana, states that do more spring application, they use liquid fertilizer. So if we had to replace our ammonia system with a liquid system because of policy or regulation, this has a major disruption in the fertilizer logistics system and the cost to you as growers and the ability of our industry to really service you the way that you need to be. So put this in perspective from the nutrient loss reduction strategy. We put on every year in Illinois, this kind of blows your mind, 2.3 billion pounds of nitrogen fertilizer. So we have an awesome fertilizer and crop production industry in Illinois. The nutrient loss reduction strategy says it would be nice if agriculture could reduce that by 336 million pounds, which, guys, is a big number. But if you compare it to what we apply, simply speaking, it's 7%. So as Lauren said, can we make an incremental percentage difference in reducing our losses? And that's why we all feel confident that given what we know now, that we can do this. And by the way, that 336 million pounds is worth $168 million that's going down the Illinois and Mississippi River to the Gulf of Mexico. It would be nice to keep that value back up here in the upper Mississippi River Basin. All right, talk a little bit about why it's so important for you guys who fall apply nitrogen to steward it properly so that we do not lose this important fertilizer tool. In the nutrient loss reduction strategy, it says, if we move all the fertilizer to the spring, it will only cost the farmer $18 an acre. And they looked at that, and they looked at the price, average price of fall ammonia to the average price of spring UAN, $18 a difference. So pretty simple, right? That's the struggle with all these policy documents, is they don't dig down into what truly goes on in the marketplace. So we looked at it as the fertilizer industry and thought, okay, if we truly did have to replace our infrastructure statewide to go to a more spring applied system, just the cost of replacing our ammonia terminals, which we have 13, we're blessed to have 13 ammonia terminals on the pipeline, most of them. With upright UAN systems, it would cost $2 billion. These are 2008 numbers, $2 billion just to build the storage. Does not account for the cost that CF and Coke and Agrium would have to change their production system to produce more liquid fertilizer versus ammonia. The retailers would have to inventory it for 10 or 11 months, and they're excited about that, let me tell you that. And try to figure out how to position all that for a spring season. And then how we deliver it to the farm. Think about it again, 2.3 billion pounds of nitrogen put on all in the spring. Now, who here believes that we wouldn't have any issues with nutrient loss if we did that? Because we never lose nutrients in the spring, right? Sure we do. And that's the perspective that the research is going to help us find ways to manage a fall and spring system, reduce those losses to keep you guys from getting into a situation where we have a supply and demand issue that will not be good for farmers, and certainly takes away a valuable tool that I'm going to show you has proven itself to be very well received and a very good way to put on fertilizer if you do it and manage it correctly. So N-Watch, as Jennifer said, has given us a window into the soil nitrate. What happens to the fall applied nitrogen? One of the most common questions I've always gotten working for the fertilizer industry is, oh my gosh, Jean, how much longer are we going to have fall applied nitrogen? It's always everybody's favorite, you know, kicking dog. It's always the bad thing, right? Because the assumption was that you're putting it out so early, it must be gone by spring. Well, because of N-Watch, we know now that it's not all gone by spring when it's applied according to the agronomy handbook. 50-degree soil temperatures with a nitrification inhibitor. Now, I've worked in the industry long enough too that I remember when ammonia was inexpensive, well, we'll just put on a little bit more rather than use an inhibitor. So N-Watch has showed us how valuable the inhibitor is, because guys, this is not always about yield anymore. Your biggest liability is losing nitrogen. It's going to cost you way more to get an NPDES permit for your field tile than it will be to use nitrification inhibitors. So N-Watch showed us, this is last spring, this is a fall application of anhydrous ammonia done after the soil temperature reached 50 degrees. Without N-Serve, by May the 10th, this is how much had converted to nitrate in the leachable form. We still had 35% in ammonia. When we used N-Serve, 67% on May 10th was still in the ammonium form, the non-leachable form, and 33% is nitrate. So those numbers are almost the exact opposite. So if you take away nothing else from this conversation, if you fall apply nitrogen and you want to help Illinois agriculture keep fall applied nitrogen, you have got to use a nitrification inhibitor, a proven nitrification inhibitor. They work. Now, where are we with spring applied fertilizer? So the concept sometimes is, well, I put it on in the spring, I don't need to protect it, right? We used N-Watch and we did the same thing with spring applied ammonia. These were just taken these last May. So again, we never had this before. NREC gave us the ability to look at this from a research standpoint. So spring applied fertilizer, this was an April application of anhydrous ammonia, tested on May 26th. 90% of it was in the nitrate form. 10% of it was in the ammonium form. With stabilizer, look how much is still in the ammonium form, look how much is in the nitrate. A tremendous difference in the amount of stabilized spring nitrogen. Now you guys know this year, you know, how much growth did we have by May 26th? You know, the crops have been a little bit struggling out there. So again, how do you protect that nitrogen to keep from losing it to the environment? That millions of dollars that goes down the river, this is a way to do it. And just quick comparison, these slides are all on the NREC website. I'm just showing you a few snapshots of what we pulled together from this research. So this was a fall anhydrous ammonia rate trial compared to a rate trial in the spring. This was in the year 2014. So when people say fall applied nitrogen is bad, I just show you this slide. These yield response curves are on top of one another. There was maybe just a little bit more from the spring, but not a lot. But again, this was a proper application of fall fertilizer. So I want you guys to feel excited about our ability to not lose an important tool in Illinois' nitrogen toolbox and to be proactive on this so we have science to back up your choices on the farm. So NWatch also allows us to predict where we are at the end of the season. NWatch tracked a farm field that had a fall application, 140 pounds, so this farmer lowered his nitrogen rate, came back with the spring split, and we watched the ammonium convert to nitrate around here May and June, but then when the crop grabs a hold of it, by the end of harvest, on August 29th, there was no nitrate left in the soil. So now I can call Rick Twait up at the city of Bloomington and I can say, Rick, in McLean County, we are looking good. We don't have excess nitrogen that's going to come into Lake Bloomington in the spring, or Lake Springfield, or Lake Decatur. And you know what, guys? You are doing a phenomenal job on fall applied nitrogen. This year, Decatur, Bloomington, and Springfield have not had a nitrate issue. I wish I could say the same about Vermilion County. It's not so good in Lake Vermilion. They have different issues up there. But we have done a phenomenal job with stewardship, but you've got to keep it up because all it takes is one big headline like they had in Ohio, and then the regulatory pressures come again. So the conclusions of the research from where we are with NREC, the beauty of this is that we're 2 to 3 years into it now. We can publish this information probably in a couple more years, is build yourself a safe nitrogen system. Don't gamble on putting on too much. Don't short yourself on the other end and leave yield on the table. But that's what the university research is all about, is helping you guys build a system that's going to be reliable and defensible. So part of the other thing that we are challenged to do in the nutrient loss reduction strategy is show the government and the environmental groups, are we making progress? Because you know what, when we have rains like this, sometimes the progress is not going to show up in their water quality all the time. But they've asked us, if you show us progress on best management practices, we will take that as a symbol of progress. So look at what you guys have already started. This is why Lauren and Jennifer and I feel so confident about this, because Illinois agriculture is well on its way to being better stewards of nitrogen. Our fall fertilizer sales have gone down 30% in the last 3 crop years. And no one in the fertilizer industry is complaining about it because we can still use our equipment, our toolbars, our nurse tank, we can split the workload, we've got the people to do it, and our spring sales are up a little bit. But we like to keep that nice balanced system and give you guys choices of splits. And look at the sales of nitrification inhibitors have gone up tremendously in the last 10 years. This is an example, perfect example of how voluntary practices work. When you have the education to drive these choices, we have made tremendous progress in fall applied nitrogen. So this is a success story that we get to share to show the critics of people that say, well, voluntary doesn't work, you have to have regulation. This is an example of how it works. And I'll end the research side with the phosphorus slide. This is also available on the NREC website. This was a study done in Champaign County. The ground is as flat as this. People think I don't lose phosphorus because it's so flat. So we studied a field. We simulated 2 inches of rainfall on that field. The only time that phosphorus truly didn't move was when we strip till deep placed it. Because when we broadcast no-till or broadcast, it did move. Phosphorus can move. So again, think about how you manage your phosphorus so you keep it from moving off the soil profile. So here are the best management practices for fertilizer. And again, fertilizer management is probably not going to get us everywhere we need to be with the nutrient loss strategy, but is an important component. Do not apply ammonia until the soil temps reach 50 degrees. And I think we'll all admit, we used to start in the middle of October, right? Man, October 15th was in the agronomy handbook, let's go. It's not that way anymore. The agronomy handbook says wait till 50 degrees. It usually doesn't happen until November. Use a nitrification inhibitor, and in the springtime, also think about a urease inhibitor because air quality, you guys, is going to be the next thing that we face. Use a good reliable nitrogen rate and split your total rate so you don't have everything out there at one time. Reduces the risk of catastrophic loss. Soil test in the spring. Now, why am I saying that? Because the best thing that we can do is prepare to get work done in the fall. Especially if you're going to plan on putting dry fertilizer on in the fall, let's get it done. Because the last 2 years, we waited, we didn't know, prices are high, commodities are low. I think I'll wait. And we've had situations where we've been spreading fertilizer on frozen snow and soil. Frozen soil and snow. Not a good situation. It's been banned in Ohio. The expectation is that it will be banned here unless we can get ahead of it and say, we've got a handle on this. We shouldn't be doing it. Soil test in the spring and get ready to put on your dry fertilizer. And also, if you soil test and you're ready to go, those variable rate applicators can make a great deal of progress in minimizing over-application of phosphorus. And if you can incorporate your dry fertilizer in some way, shape, or form, it'll protect that from running off the surface. And also, this, like Mark Davis said, takes a little bit of phosphorus to cause a water quality issue. And this is the final slide I'm going to leave you with. I hope everybody that leaves this room, whether you're a fertilizer dealer or whether you're a farmer, do not put yourself in this situation, because just think about me for a second. I represent the fertilizer industry. And then we have floaters out on the snow, and people see this, and my phone rings in my office. And let's say the environmental groups say, well, this is wrong, and we're going to introduce a bill down at the state capitol. We're going to put all kinds of other bad stuff in it too, but we're going to focus on this. And then I have to go up there to the Senate Environment Committee, and someone will say, well, you guys support the 4 R's, right? Right source, right rate, right time, right place. Is this the right time? Is this the right place? So I won't answer that question. I'll let you answer it. This is what we cannot do. Because I'm going to bring up Dr. Hafe now. I want you guys to feel good about everything we've done, because we have a head start on feeding the nutrient strategy with the research. Now, the NREC brochure is on your table. There's 20 projects this year. The best thing about NREC, it cannot be swept. Because I tell you what, if it could be swept, it would have been swept. The government cannot get its hands on this money. This is going to sustain this whole effort. And there's a project going on just north of you at Illinois State University with Dr. Armstrong. We're lucky to have Bob Hafe here. He's the research coordinator for NREC. He makes sure all these projects get done and get done right. And he's going to tell you just real quickly about the project at ISU.
Thank you, Jean. I didn't really plan on being on the program this morning when I came, but it's a pleasure to be here and to be able to talk about the work that is going on with NREC. This is the greatest research program that has existed since I came to Illinois, which is a long time ago. And it's a program that's going to move us forward very rapidly in finding new opportunities and new options for you to consider on your farm. Okay, I can change them here. Thank you. I think I can. Hang tight, though. These new things don't always work for me. This project is being done here in McLean County, and it's being done by the people from ISU. Dr. Armstrong is leading the show on this. It's a project where he's looking at different options for putting on fertilizer, time of application, and it's a tile drained operation, so he's monitoring everything that's happening out there. These aren't my slides, so I may get ahead of myself or behind myself here real quick. But he's looking at, let me just get to the treatments real quick. A control plot out there that is not getting any nitrogen, and we do that because we know the soil is going to give nitrogen every year, no matter what we do. And so we want to monitor on that. Also, this is a new tile system. And when you disturb the soil, you're going to release more nitrogen. There's no doubt about that. So we had to get a measure on that in this particular experiment. He's also looking at time of application, fall and spring, looking at with and without cover crops, and the impact that will have on the amount of nitrogen coming out of those tile lines. Again, a field here in McLean County, a pretty flat field. It's all automated and it's sampling, so even if it rains at night, the system is going to get the samples and they're going to get the analysis on what comes out of it. Now, I think his graduate students have on their phone when it's raining, and they get an opportunity to be out there at night too on some occasions to make sure everything is working right. The cover crop aspect of it, they've had good success there in getting stands. This little bit over here on the right is early fall growth. I don't know why this is cracking so much on me. And then the growth in the spring. And the purpose of the cover crops, as was mentioned earlier, is to hopefully take up some of the N that is left over in the fall, incorporate it into that plant tissue, and then recycle it back in for the next year. The data that he's collected shows that it is in fact working. These are nitrate values with and without the cover crop. With the cover crop is the line to the left. There is less nitrate in the soil where the cover crop has been because it's been taken up into the plant. The line on the right is the amount of nitrate that was left over that was not removed by a cover crop. So, yes, it is doing its job, and it will recycle back at some point. Maybe not the next year, but certainly soon. These are the examples of what's coming out of that tile line. The concentration of nitrate on the left, this is spring versus spring with a cover crop. Spring applied in, and then spring applied with a cover crop. And you can see the amount coming out of that tile line is less. And then fall applied, and that's the highest one. Now, I think Lauren or Jennifer talked about 10 ppm as a critical value. That's a drinking water standard. None of these are that high, but the fall applied is approaching the 10 ppm level. Fall applied with the cover crop is down around between 6 and 7, and the control, again, remember this had no nitrogen applied, is up in that 7 to 8 part per million range. I'm going to end with that, but one other comment. Lauren talked about the Iowa situation. The water people out there are removing the nitrates from the water before they move the water out to the public. Do you know what they do with the nitrates they take out of that water? They put it back in the river on the other side of the plant. I find that really interesting. I know there's nothing other practical that they can do with it, but basically they're a point source pollutant because they're putting back concentrations higher than is allowed. So the next city down the line gets to take it out. With that, I've enjoyed being here, and I'll turn it, Jennifer. All right. Now if I can get this out of my pocket.
Thank you, Dr. Hafts.